Good morning, it's me. Today I'm going to have you do several things, all of the things that you can find in Canvas as you've opened it up hopefully already. First you're going to watch this video, which is over section P9, linear and absolute value inequalities. Next you're going to have an assignment, a smallish assignment from this section that's in your book, and then there's also a worksheet that has been attached over solving equations, so some extra practice on the things that were on your quiz. And by the way, your quiz scores are in SIS, so you can look on there and see how you did on that quiz. So today we're going to start with this, and we're actually not going to talk about solving any inequalities today, but we do need to talk about the way we write our answers and the way we look at graphs with inequalities. So we're going to talk about the old way that we used to graph on a number line, which was to have a number line and to have a couple of points. Maybe I'll have 2 and 4, and we would use an open circle, and we would use a closed circle, and maybe in the middle there. And this is great. It's not a bad thing, but we don't really use it anymore. And in fact, what this means is that 2 is less than x, which is less than or equal to 4, or that x is between 2 and 4, does not include 2, but does include 4. And we've talked about this before when we were talking about domain and writing things in intervals. That now we're going to be using, instead of open circles and closed circles, we're going to be using parentheses and brackets. Okay? And there's a few different things that we're going to talk about. So I'm going to make a little chart up here. We're going to have our interval, the way it would be written in interval notation. We're going to have that interval written in what we call set builder notation. And we're going to have a graph. Okay, so we're going to talk about I'm going to look at 4 different intervals this way, and then we're going to look at a few examples, and that'll be almost it. So for instance, if I have the interval that is parentheses, a, comma, b, parentheses, if I wanted to write that in what we call set builder notation, remember anytime we are trying to denote a set, we use a curly brace. So we're going to have then x, a bar, which really means like such that, so we might say x such that, and then I'm going to write this as an inequality. A is less than x, which is less than b, and then I need to close my set with another curly brace. The way that would look if we were graphing it is on a number line, A, B, and we're going to have parentheses, and they're facing inward so that we can see that we're talking about the numbers between A and B, but not exactly A and not exactly B. Okay? The next one we might have using brackets. So bracket A, comma B, bracket. In set builder notation, a lot of this is going to be a little bit similar, where we've got the curly brace, x such that. Now we'd like to say that x is between A and B and includes A and B. So we'll say A is less than or equal to x, which is less than or equal to b. And the way we would draw that on a graph is with an A and a B and a bracket on A and a bracket on B. Okay? We have a couple of infinite intervals that we'll talk about. So A, comma, infinity, and anytime we talk about infinity or even negative infinity, we always have to use a parentheses there. We've talked about that with domain before. So this one would say that I want all the x's such that x is greater than a. Okay, so notice that I've got a parentheses on the a, therefore this is just greater than, not greater than or equal to. If I'm graphing that, it looks like this. A, parentheses, really going that way. Sometimes I'll maybe color in the arrow a little bit just so we can really see it. Okay. And the last one we'll talk about in this way is going to be negative infinity to b. This time I'm going to use a bracket on the b. So I'm going to have all x such that, in this case I want now x to be less than or equal to b. So to graph that, I'm going to put a B on the number line. I'm going to put a bracket facing the left towards negative infinity, and maybe I'll color that in a little bit. Okay? combinations that we can have when we're talking about intervals. So we can have parentheses on both sides. We can have one parentheses and one bracket. We can have brackets on both sides. We can have infinity or negative infinity, and it can be paired with a bracket or a parentheses on the other number. Okay? So there's a number of those that happen. Okay, so let's look at a couple of examples of looking at intervals and rewriting them. So express the interval. In set builder notation. And graph. Oops. All right, the first one we're going to look at is -2 to 5. We have a bracket on -2 and a parentheses on 5. Okay. So to write this in set builder notation, I'm going to say that x, it's all x, such that, and we want to indicate that x is between -2 and 5, but that it can be equal to -2, but not equal to 5. So we'll say -2 is less than or equal to x, which is less than 5. And if I'm graphing that, I'm going to put -2 on the number line. I'm going to put 5 on the number line. The nice thing about interval notation is that it looks exactly like it would look on a number line. Bracket on the -2, parenthesis on the 5. Okay? Pretty straightforward. Let's just look at one more. If I have negative infinity to -1, and I want to write this in set builder notation, it's going to be all the x's such that, that's what this notation means. In this case, I want -1 down to negative infinity, so x has to be less than -1. Notice also that it's just less than because x cannot equal -1. It can be very, very close to -1 though. On the number line, we'll put -1 on the number line. We know we want to go to negative infinity, so the parentheses will go this way, and I might color that one in. Okay? All right, the next thing we need to talk about with sets is intersections, or sorry, with intervals, is intersections and unions. Oops, U-N-I-O-N-S. Okay. So we're going to talk about unions and intersections, and I just want you to recall, we've talked about unions and intersections before. Remember, a union, which we use this symbol to show, is sort of like a marriage. Okay. So the guy brings all of his stuff from his apartment, the lady brings all the stuff from her apartment, they put all their stuff together, it's a union, and that's a marriage. Okay. When we're talking about an intersection, which is this one, sometimes we can think about streets the way that we talked about if someone had a car wreck right here. What street are they on? Are they on Y Highway? Are they on 58? And we said, well, they're actually in the intersection. So the intersection, which is like right in here, is all the things that the two streets have in common. All right, so an intersection is what they have in common. All right, so let's look at an example of how we can use a union and intersection with intervals. Let's look at this one. 1, 3 intersected with 2, 6. Okay. Now, the easiest way to do this and the way that you're going to be instructed to do it in the textbook and on your assignment is to use number lines. So what we're going to do is draw a number line for each of these. And I'm going to be very careful when I draw my 2 number lines that I keep them stacked up nicely. 1, 2, 3, 4, 5, 6. Maybe here I have 1, 2, 3, 4, 5, 6. And then I use the same exact number line below it because this is going to make it easier. So I'm going to graph the interval 1, 3 on the top one. I'm going to graph the interval 2, 6 on the bottom one, and then we're going to see where their intersection is. So 1, 3 is going to look like this. 2, 6 looks like this. And I really want to be thinking about where do these two intervals overlap each other. Here I have here, and on this one I have all of this. And I want to know where they overlap each other. Well, they overlap each other between 2 and 3, but remember on this one, because it cannot equal 2, it's going to be 2, but it can equal 3 in both cases, so we're going to use a bracket on 3. So the intersection of these two sets is the set 2, 3. Okay? Let's look at one more like that. 1, 4 unioned with 2, 8. Okay. Okay, so again, we're going to draw number lines. In this case, my number line needs to go from 1 all the way up to 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, there's 8. The next one is going to go the same, 1 to 8. And we're going to keep those two number lines consistent with one another. So I'm going to graph 1, 4 on this one. So here's 1, 2, 3, here's 4. Okay. And maybe I'll even use a different color here. So we're talking about all of this space. Okay. 2, 8 is going to use brackets from here up to 8, which is all of this. And remember now, we're talking about a union. So this interval is going to bring all of its stuff. This interval brings all of its stuff, and we put it all together in one interval. Sometimes it's even helpful to go ahead and make another number line. Here's 8, here's 1, and kind of see what happens. Well, it goes from 1, 2, 3, 4, 2, 3, 4 is all the way up to 8. So the union of those two is actually going to be parentheses 1, 8, bracket. Okay. So we took the two intervals and basically pushed them together. Versus the intersection over here where we had two intervals and we were trying to find out where do they overlap each other. Okay? All right, so this is the kind of things you're going to be doing on your assignment today. Now, having said that, the instructions on the assignment will say to find the union or the intersection using number lines. You have now seen a couple of examples of how we're going to do that. This is what I'm going to expect to see on your assignment, okay? I know that you don't want to. I know that lots of you think that you don't need to show all of that, but that's what I want to see on your assignment, okay? All right, so the assignment is going to be on page 126. You're going to do 1 through 26 all. And it is several problems where you're writing intervals in set builder notation and graphing, and then several problems where you're doing unions and intersections. And that's it, okay? All right, I will see you on Tuesday. Make sure that you get all of this work done. If you have any questions, please stop by and see me on Monday. Have a good long weekend, and I will see you next week. Bye.